baking's really tricky sometimes, and it causes a lot of guys problems. So I want to go over some basics here on how baking works, but also taking a look at how you can bake cylinders and use custom cages. Because when you're using sharp edges on your models, a lot of times you're going to end up having to use a custom cage, unfortunately. And the better, simpler solution here is more than likely to just use chamfers on all your edges if possible, make everything shade auto smooth at 180 or shade smooth in the newer versions of Blender, and then use weighted normals. But we're going to save that for another video. This one, let's just talk about the sharp edges issue on cylinders for the most part. And we'll also just talk about baking on a plane first. So we're going to get that started so you guys have a better understanding of baking in general. So if we create a plane like so, we're going to tag this _low for now, okay? And if we create a cube, shrink it down, we'll do some edits on it real quick, just make a little shape here. I'm going to jump into a top view real quick by holding Alt while orbiting. Turn the matte cap to a normal one. And we're going to turn off cavities just a second. We can't see nothing. So this is like lesson number 1 here. Whenever you're baking anything, you need to usually create some kind of tapered effect, or you need to do bevels, right? So if I was to go ahead and take these two here, I'll bevel one and I will taper the other. So when we look at it from the top view now, we'll see this. This has to be what is present from your high poly to your low poly in the cage, right? You need to be able to see some kind of data there in order to generate a normal map. Otherwise, it just disappears. So you can't use sharp edges in that manner necessarily, right? Where you just extrude something up. Now, with this out of the way, we can consider these our high poly models, and this is our low poly model. But we want another plane. So we're going to create another plane. This is also going to be part of our high poly. So we're going to grab, we'll turn the low poly off for a sec. We're going to grab these, join them together, Control J. Oh, actually, before we do that, let's apply that bevel. Grab these, Control J them together. This is going to be our plane _high. Okay. We'll go back to our regular matte cap for now, and we'll have this going. We're going to go over to Substance Painter. I want to show you what's going on over here. So plane low. Okay. I'm going to go ahead and export this as an FBX. And I just want to make sure I'm using the selected object only. We have plane low selected. Make sure it's visible in the viewport or it doesn't export right for some reason. But whatever the case, plane low, selected object only. Copy and paste the text there so we don't have to write it back out. And we can select plane high, do the same thing. Make sure it's selected object only. FBX files, right? Let's go to Substance Painter real quick. We'll do a new Substance Painter here. We'll go ahead and just use the Blender default setup here. 1024 OpenGL is fine. We'll select the low poly real quick. Open it up. And the naming convention here, _low, _high. Let's just talk about that real quick. When you're working in something like Substance Painter or maybe Marmoset, usually _high, _low for the objects that should match each other, basically. So in our case, plane, but if you had like handle 1, handle 2, you do handle 1 high, handle 1 low, handle 2 high, handle 2 low, right? So you'd have all these different objects with all their matching parts and components, basically. So over here, we go back and we're going to go to the Bake tab, a little croissant there. And we're going to load in this high poly. And now we'll get this kind of result going here. Now notice we have a max frontal and a max rear distance. So let's just bump up the frontal distance here and look what happens. We cover that up and it's no longer red and we're good there, right? And we can just click bake real quick and see what we get here. We can hide the results of the baking visualizer. Okay. So it bakes out just the way you would expect it to, but the whole thing here is I wanted to point out that when we change that max frontal distance, it's going out like so, right? Okay, so when we're in something like Blender or other programs later on, baking perhaps, usually cages are generated automatically. That's what that was. In Blender, if you choose to bake over here, you won't see that, but it does exist. So if we go to Render Engine Cycles, Bake, and let's say we're doing a selected to active, which is high to low poly baking, basically. Extrusion amount here, okay? This is going to be the same as creating an automatic cage, okay? Matter of fact, if you need to figure out how far you need to go, you can use a measure tool. A lot of times you can measure the exact distance you need. So like 0.2 in this case, maybe, right? So you'd be able to type in 0.2. And when you go to bake, you'd be able to utilize that. Now, I'm not going to show you baking here in Blender because honestly, it's not the best place to do it. Get Substance Painter if you can on Steam or buy Marmoset and use those. It's much better. Now, here's the thing. We can go ahead and talk about the cage for a second. So we got this low here. We're going to duplicate it. And I'm going to give it a material. I'm going to call it the cage material. And I'm going to set this to material. Usually I got it on object. So this material, we can set the viewport display to something like blue and turn the alpha down on it. So we have something like this. Now, if I take this into edit mode and I hit Alt-S and I move it like so, you see something similar here? Okay, so Alt-S is shrink or flatten, but it actually just scales along normals more or less. And so we can offset even if we need to. And it's doing basically the same thing we're just doing there inside of Substance Painter, right? You can even see there's the offset distance here. It's almost 0.2. It's kind of interesting, right? So here's the thing about this, though. When we look at meshes here with an add-on, the measure it add-on, right? We click show, mesh debug, all right? And I just want to select, not the high poly, just the low, and this one would be the cage, okay? So when we select cage and low, you see how they match up here? It's a 0, a 0, a 1, a 1, a 3, a 3. So the vertices have orders to them, and they have a count, basically. This is important to understand because when you're working on meshes later on, you're trying to go to some kind of software where this really is super important. Certain bakers rely off of this information. For example, you'll often get errors that say you have a mismatching vertex order. That's what that is. They have to match up. So when you get into more complex mesh later on, you actually want to triangulate your base, low poly usually, to send it to other software, right? That kind of sets it up with the triangulation as you see fit. Let's turn this off a second. So it's going to triangulate this plane into 2 triangles, basically. But this one over here would need to be triangulated as well, and it should have the exact same setup. When you run into issues with the counts getting messed up, this even happens in Blender, by the way. When you do this little Alt-S thing on more complicated mesh, sometimes the triangulation changes, and for whatever reason, it changes the vertex order. Who knows why, but it does. And so what you would end up doing is you would want to apply the triangulation and then inflate your cages if you need to, right? So that's the big thing there. You want to apply the triangulation. So when we do this later on, you'll understand what's going on here. But yeah, a cage is a cage. And so you can actually take this and just export it out. Call it a cage. If you ever want to use something like that in Substance Painter, you can certainly do that. You use cage file, boom. It's just another model, basically. It's a copy of the low, and it's, extruded outwards, something like so. And so you can actually bake off that. You don't have max frontal distance or rear distance no more, because the distance is controlled by how far you push it out, basically. So that's what's going on there. And if we bake that, it's going to bake just fine for the most part. And cages are oftentimes more accurate and better because you can actually kind of skew around the normal directions, or excuse me, the way it's working anyways, is that we're creating raycasts from those vertices, right? So like vertex 3 will meet up with vertex 3, or 2 will meet up with 2, and they're seeking each other out. So even if the cage was modified heavily, what ends up happening, like we have this way out here, we can change that ray direction, right? So that ray direction is now going to shoot way over here from there to there. This is going to help us on the cylinders later on. This is why I wanted to go through this first, because it's really hard to understand otherwise, in my opinion. So let's just go ahead and start up a cylinder. We're going to do a 32-sided one here first. I'm going to keep this really simple, something like this, and maybe we do just a little extra here in the middle, perhaps. So we do an inset, and we got something like that. Maybe inset here, extrude that down, scale it in a little so it has a little bit of an edge there. Great. And so we have something going on now. I don't know if I exactly like the design. Let's try this instead. Okay. So we can shade this auto smooth. Now, here's the thing. If we wanted to make this have a bevel on it, but this was like good enough for a game model, we can bake a bevel from, and we could call this like a high poly, and we can bake it to a low poly. That's the same thing, basically, if we really wanted to. You don't always have to convert these into like subdivision meshes. Oftentimes it actually causes more problems than it helps. So if you want to bake something like this to something that's a little bit lower poly, where it's just without the bevel, that could be a high and a low poly, guys. Like, you don't always have to overdo things sometimes. Sometimes this works out just fine. Maybe bump the counts up a little bit on the bevels or something, right? But we can definitely do better if we, make it a subdivision mesh. So let's go ahead and do that. I am going to duplicate this and hide it real quick so we can make it into a low later on. But what I want to do here is get rid of that bevel. And we're going to just manually bevel things real quick. Just selecting these edges. Well, we could have beveled with the actual modifier still. I just want to bevel these all. Mouse wheel up once so that we have segments 2, shape 1, something like this. I can hit Control 1, Control 2, shade it smooth. Now we have a really super smooth setup here. This little middle section like this can cause issues. So inset it, merge it center. You can bake this. It should look fine. But if you want to grid fill it so that you end up having a perfect quad mesh inside there, you can do that as well. So delete it, Alt click, Control F, and then you can grid fill, right? And you can offset it so that it lines up to a direction here, basically, something like that, right? So we can do grid fills as well. Now, so we have a cylinder, and this is going to be cylinder underscore high, okay? And we got that. Now we had the other cylinder that we created. Let's hide the high real quick. This is going to be cylinder underscore low. Still has a bevel on it, apparently. All right. And while we're at it, let's get rid of that bevel. And let's talk about this real quick. Actually, we'll add a bevel back. We're just going to do a 1-segment bevel. We're going to convert this to a mesh and apply that real quick. Okay, so this is usually what people think of when they think of low polys. They think of really low poly models with sharp edges, right? When you start to do things like chamfers on every edge, you shade it auto smooth and you bump this to like 180. You can apply a weighted normal modifier, keep it sharp if needed, usually actually turn that off. Use face influence if needed as well. Face influence is tricky. Sometimes you still have shading issues. You can Alt N. You can set face strengths to certain big faces, usually to strong, and it might fix up some of your shading issues. So that's good to know. But the main idea here is that like this right now is shading very well on its own, right? Just with a chamfer and a weighted normal modifier, this is kind of good because when we look at these things later on in edit mode, what we're going to find is that this is more or less smooth shaded in the newer versions of Blender. If you just smooth shade and weight normals, it'll do the same thing, right? In the older versions, you got to shade auto smooth at 180. Now, if we turn on split normals though, and we make these maybe a little bit bigger. All right, so these are all single split normals basically. So every vertex gets one of these little lines. If we were working on this one where it's shaded maybe flat or shaded auto smooth, every time you have a sharp edge, it splits into 2. This is where it causes a lot of baking issues for you because it's seeking kind of data in different directions. So you get like different normals, basically. It's kind of interesting how it works out, but it's not super important to understand that entirely. We're going to make it work, but it's tricky. You have to use a custom cage. You have to use sharps. You have to have seams. It's a bunch of nonsense that goes into it really, but we can make it work out. So this is much easier to bake, but you know, that's for a different video maybe. This one, we're going to focus on this one. So here's the thing with this one. This needs to be broken up, right? And every sharp edge has to have a seam, right? Every sharp edge. So we're going to Control E and mark seam. Shade auto smooth already makes them sharp. We don't have to actually mark them sharp, right? But they need seams, all of them. So you see how this is going now, right? We're doing lots of seams here. And this is actually less performant from my understanding, although I didn't measure this and go through a bunch of data to figure that out. It's just reading on forums. But supposedly this, you know, is going to eat up quite a bit of data because every time you do sharp edges like that, you split the normals, it creates more vertices in the data basically, right? And so now you're adding more seams, that creates more vertices in the data again. So it's like double or tripling up the vertex count almost of sorts, not entirely, but just doing chamfers might actually be a better situation for performance, believe it or not. So just keep that in mind. It gets a little bit tricky, right? But we do add seams in here, which is great. And what I'm going to do is go ahead and split this on this side over here, like this. I'm going to mark a seam all the way down this one side. Now, usually I stagnate these so it's not all on one side, but for this video, we're just going to go for it. We're going to press U, unwrap, and that should give us an unwrap like so. These here, when you have edges doing this number, right? A lot of times it creates aliasing on it when you bake out a map. This isn't what you want. So if you can manage to straighten something like this out, if it's all quads, you can use the text tools add-on here, just rectify it. Those will straighten out super fast. You don't even have to mess with them, but you have to have quads, unfortunately. You can straighten out non-quads, but it gets a little bit tricky doing that. And so we're not going to focus on that in this video, but it's definitely something you can try doing as well. You see this one still looks like a cylinder basically, or a circle. it's probably split. We can just rectify it. So sometimes you got to watch out for that one. All of these it seems to be doing this. And so that's what that is. So we want these kind of straight left and right, up and down if possible. All right. And if we can, straighten something out, do that. So we can go back, we can pack this thing. Take note, if we pack islands with default settings, oh, it actually worked out okay. Sometimes it'll rotate things at like 45 degrees. So when we want to pack islands here, set rotation method to cardinal. Okay. And that'll just keep them going up and down, left and right. That's all that pretty much does. You can give this thing some margin as well. Try out different numbers here. 0.1 we'll go with first, see if that works. Boom. So when you're doing a 4K image or 4096 by 4096, 32 pixels of separation is usually what they recommend. You can get away with less, but that's usually the recommendation. And then it goes down from there. So a 2048 by 2048 would be 16 pixels. And then 1024 by 1024 would be 8 pixels, and so on and so forth. Powers of 2, basically, right? So we got these nice and separated. That's all we need for now. We're not trying to create a stellar UV map pack here, but that's what we need. Okay. So this is now our low. We have our high. Let's go ahead and export these things out. Let's just copy the names, export out the FBX files real quick, and we'll do that one there. For the low, before we export it, make sure that we add a triangulate to this one and keep normals. And we'll go ahead and export out, get the name here real quick. We'll go ahead and export out an FBX. Selected object low. Let's go to Painter again. We'll do a new one. We'll select our low cylinder. Okay, it's all set up pretty much like so. Nothing checked really. It comes in like this now, okay? Now let's go to the Bake tab. And let's load up the high poly. Cylinder high. And we can do this one over here. We may want to triangulate the high as well, but usually if it's quads and it's high poly, it doesn't matter as much. So that'll be fine probably. Now the thing is that if it's ingons and stuff like that, you definitely want to triangulate it. All right. But we have it in here now. If we just go ahead and do a straight bake real quick, no, we're not changing any settings just yet. And we hide this result or the cage and we get a bake out like so. We can see it works out pretty well. There are some questionable things going on here. So this is the aliasing effect that I was talking about. That can happen. Some of these edges are really pronounced here. We can see quite a bit of what's going on here. We didn't have as many errors as I thought we were going to have, but you can kind of see a little bit of one here at the bottom where we get like this dipping effect where it's like these little dark spots. Usually that's more pronounced and it can happen at anywhere on the model. It can happen up here. It can happen on the side. There's all kinds of little weird things like that that can happen. So you got to be careful with that. Now I'm suspecting that the main reason we're not having too many issues is that right now, this is a fairly high count for the cylinder surface, right? So this is actually what Marmoset recommends when you're looking at their introduction to like how to use Marmoset. But basically, if you can make your cylinder shapes match the high poly closer, you'll have a better bake. That's kind of thing number one, right? But because I am who I am and I want to make as many problems as I can for ourselves, let's say we don't have the budget to do this, right? So what I'm going to do is I'm going to select all these as a ring. And I'm sorry if this is a little confusing, but selection methods, you need to learn these things. Select loops, edge rings, edge loops, boundary loops, inner loop regions, and checker deselect is super useful here. So I'm going to do one edge and I'm going to select edge rings. And now I'm going to go ahead and hit Q. I have checker deselect here. Okay. I can checker deselect. I don't want to have this seam selected. So if it is, we can offset it if needed. Okay. Now I can select loops by just using a shortcut I've set up to select loops. All right. So otherwise it'd be up here, select loops, rings loops, right? Okay. So I can hit Control X now and I can dissolve all that. I can reduce the cylinder count here and the UV should actually be okay, fine, because we didn't dissolve that UV seam. So surprisingly, this should work out well. Let's try to export this FBX now as cylinder low. Maybe we reduce it and then we go back to Painter. And to update this, we go to Edit Project Configuration. We select the cylinder low this time and we just click OK. You see it reduces it. We bake this now. We should have a little bit more errors in it, hopefully. That was the whole point of doing this video, is to try to run into errors. Okay, now you're starting to see it, right? You see the cylinder reduction here starts to make that even more apparent. Okay. And so that becomes a problem. How do we fix that if we absolutely need a lower polygon cylinder? Unfortunately, you can't get rid of it entirely, but there's little things you can do to kind of make it better. And so that involves using a custom cage usually. So we're going to make that. Let's do that right now. Okay, so custom cage, we're going to duplicate the low. We're going to go ahead and just name it outright real quick, cage. We're going to apply that triangulate. And we're going to go ahead and go and create a new material. We'll create our bake material right here, or our cage material would be the better name for it, I think. But anyways, we go ahead and do that. Viewport display, change it to blue, turn the alpha down. Let me tweak my viewport here. And we can see we have this. The cage needs to encompass the high poly and the low poly. The high poly and the low poly can pretty much lay one on top of each other. They can intersect each other. One doesn't have to be over the other. So they're fine the way they are. Now, the cage, on the other hand, has to encompass both of them, the high and the low. So when we do this, we want to just go through here. We're going to do it kind of like Marmoset or even Substance Painter would. We're going to select the cage, go into edit mode, hit Alt-S, and we're going to pull it out like this, right? Okay. So it's just expanding like you would expect it to do in any other software. Offset even here if you want to. And now it should fully encompass everything, right? So we're going to bake this one first just so we can see what kind of results we get out of it. But we have it triangulated. Everything's going good here. We want to grab the, not erase the name, grab the name. Here we go. Let's export the FBX. And so we'll have cylinder cage now, selected object only, boom. All right, when you're exporting, just make sure everything's visible that you're exporting, okay? So the cage is out. Let's do it. Let's go use cage. Let's click here. Cylinder cage, FBX. Okay, now we don't use max frontal or rear distance. However far we push the cage out sets the frontal distance, basically, or the ray distance. So that's what that is more or less doing. Now, we got it all set up. If we want to look at this, you can see it's updated. It's actually using our cage now, not the one we pushed out before. Okay, and so this is good because if we bake this real quick, like, we're going to see that it doesn't really change. It does almost exactly the same thing. And so that's kind of interesting, right? Like it's almost the same bake. And so same problems down here at the bottom in particular. And we could actually run into other little weird kind of like ray misses and things like that. If you ever see really dark little spots or sometimes bright spots even, usually that means your cage or your projection, your ray direction is not quite right. So you got to keep those things in mind. But can we fix this? That's the question, right? Yes, but it gets really tricky working with cages because just like I was showing earlier, like if you push something way far off, it does a different ray direction. You have to kind of get in tune with like what the ray directions do when it goes across the surface. Because if we were to take, for example, like this error, what causes this error? Take that as an example. We have a ray direction going from here to here. So like those vertices have the same number more or less. So it's going in at an angle here. And then, but we have this one going here to here. So everything in the middle here is kind of getting casted like this as it bakes, right? So we can end up with skewing and all kinds of other nonsense going on potentially. But because this is going to bake into this corner, we have possibly a split normal doing something like this. You see where this is going now? So we're going to be pulling like the wrong light information into this area. It becomes a mess, basically, is what's going on there. Terrible, right? So here's the thing. We just line these up very meticulous-like, and we can actually get this to start to work out probably a little bit better. So Alt-Z, select all the way through the mesh. We don't have to create a new cage or nothing right now, but we just line them up better, okay? Line them up as close as you can before it causes an error, basically. And some of these other ones you can line up as well if you think it would help it out. So like, I think these ones would look better if they were right in tune with this edge here, right? And this is the trick to baking to lower poly meshes. You have to use a custom cage. It's just how it's going to work with Blender models using sharps. Okay. So if you don't need to use sharps, you can definitely not use sharps. Even if you do use like a chamfered edge model, something like a mid poly, you might still want to use a cage. Sometimes it actually delivers better results if you do that, because just inflating, you can see it kind of does whatever it wants. So whenever you need more accuracy or to solve issues, cages are helpful. On very complex things, though, you definitely want to think about how you're modeling so that you don't have to use a cage. It's going to save you a lot of trouble, basically. Also, on big things like this section is recessed. If we wanted to bake this to a flat circular top, we could, but it gets extremely tricky with the cage as well because it sets that ray distance. So if we're ever trying to use things like floaters later on, or we're doing these big recesses, a lot of times you can't have your high poly go this far inside, or you'll just get these ray misses and it looks like garbage there. So you definitely have to take your time with this and kind of work with it to start figuring out, you know, what needs to be done and how it works and all that. But for the most part, this whole area, we could probably do the whole area down quite a bit. Maybe not the middle or the bottom or like the little inside section, but we can pull this down quite a bit like this. And if we just re-export this now, let's see what happens with this one. So we do cylinder cage, boom. Substance will reload usually the high and the cage automatically. Only the low poly, you got to go to project configuration and reload it low usually. So it should be okay now. We should be able to hit bake and it should have that little direction change basically that we've created. All right. And so you can see, oh, wait, it looks a lot better now, right? So it's not gone though. It's just flatter. Okay. And that's the trick with this whole setup or this technique. It doesn't get rid of it. It just flattens it out. So if you go too far, you'll cut off the normals here at the bottom. You cannot go through the mesh back into it. But you can get it very close usually and start to flatten it out to a point that nobody's going to notice on something like this for the most part. And remember, when you're doing extremely low poly meshes like this, usually it's for like low spec hardware, mobile phones, perhaps things like that. Your low poly meshes will never be perfect. All right. You get them as good as you can, perhaps if you need to get them very precise. This is the best way of doing it. But, you know, except there's like an acceptable level of just little small baking errors that you can get away with on most models. The higher poly they are, the easier they are to bake. But you can see this is just working out more or less flawlessly now, right? So this is the trick that a lot of you guys will run into. Baking with sharp edges. Sharp edges must have seams. You must use a cage, okay? Otherwise, you can't control that direction well enough that you're going to end up with all of these little issues like this, okay? But you need to practice it on basic models at first before you go off trying to tackle a very complex project that has hundreds of different parts. Because if you ever do need to use the custom cage, you need to understand how to control it, all right? And these little cylinders like this or little like crates or cubes or whatever. Practice on these kinds of things. It'll help you out a lot. This is the core of baking good meshes from Blender, okay? Other than this, like baking with chamfers or bevels, much easier to deal with because normally you're using weighted normals and you don't have split normals, so you don't need the cages and you don't have sharps, right? Now, there are going to be times that mid-poly models also have sharps, and that's going to mean more than likely you want to use cages on those too. It's unfortunate, but it's a reality. For whatever reason, I would think that, well, I guess using the automatic generated cages here technically work correctly, but because they only inflate in one direction, you can't have that extra finesse control of being able to like change the directions of the rays there. So that's the only downside of that. But also, you're going to end up with skewing on a lot of your objects as well. Keep in mind, now, I don't really want to go over this too much in this video because we'd mess up our cage and our low and everything else. Let me duplicate the low and just talk about this, I guess. So we'll turn the triangulate off for just a second. When we have those rays come in at different directions, sometimes we can miss details in areas or they become skewed looking because they're all being cast in at different directions, right? That's known as skewing. I've made videos talking about skewing. So if you want to go through the playlist and check out baking and like Substance Designer, Painter, correcting skews, all that fun stuff, there's tons of videos I've already done on all this, but go check them out for sure. They're going to be somewhere down there sometime back ago. But skewing's a thing that can happen. There's no skew correction in Substance Painter. There's no skew correction in Blender. Substance Designer, when you bake in Designer, you can bake in Designer. There's skew correction there, but you have to set up the skew correction manually on a texture or UV map. And then Marmoset Toolbag has like an interactive skew correction in the viewport, which is really good. It makes things super fast and easy to identify what's going on there when there's a problem. If you ever run into the problem that you need a skew correct in Substance Painter because you don't have Designer or Marmoset perhaps, remember, if we do something like this, we add certain things like loop cuts, possibly insets. we want to make something like an unoptimized low poly, perhaps, where we're trimming everything up in a way that these normals, when they go seeking for the cage later on, that, well, I don't know why we're getting draw issues now. There you go. If they go seeking in different directions like that, this one will flatten out and this one will flatten out while these ones kind of come in at weird angles, perhaps doing something like that. Maybe let's exaggerate it a little. So these will flatten out and everything will bake flat in this area, basically, right? So that's a good thing to know. It'll start to bake out flat, but these ones, unfortunately, will always kind of bake out separate like that. So if you need more resolution to keep skewing from happening, that would be something you would have to do, or use a skew correction and use Substance Designer or Marmoset. That's why everybody uses Marmoset, by the way. But Substance Designer is a really good baker as well. So, but it's not as interactive. So, play around with baking. And I don't want to overload you on too much information in this one video. There's a lot of videos already done, so check them out. And but play around with these ideas, okay? And I'll definitely be doing more on baking. I want to do more like actual asset creation on the channel. It's something I've been thinking about, how I'm going to do all that fun stuff with like different presentations and stuff. But it's this little tricky aspect of just, sharp edges need seams, right? And then they also more than likely want a custom cage for whatever reason, But if you have a more accurate model, like your low poly is more accurate to the high poly or closer matching, it bakes better generally as well. Okay. And so you can go back to Painter and you can see here, we haven't even spiced up our settings yet, right? And it's a decent bake. Like this should bake well, even at like preview sizes for the most part, right? Like 256. It gets a little bit rougher looking perhaps, but it's not terrible, right? So if we go to a higher resolution later and we turn on some anti-aliasing and we bake, it should look nicer. That's the main idea. You can see it's much cleaner now. And you won't ever get rid of every sharp edge. Like that doesn't happen, by the way. So they don't go away entirely. It will still be there, but from a little bit of distance, you shouldn't really recognize them. That's the main thing there. So don't get super picky about it. It's not going to happen. They don't go away. The higher the resolution, the more super sampling you do, the better it looks, but it won't go away. Okay. So we're going to let this one bake and then we'll end the video and we'll call this one here. All right. So yeah, play around with very simple shapes, get used to it. If you need to go to these lower poly meshes, basically. It's kind of the downside of working with super low res mesh anyways. From Blender with sharps. All right, I guess it's going to take a little while to bake that one, huh? All right, but yeah, you can see it. The more you turn the settings up, the better it starts to look. But yeah, they won't go away. I mean, that's going to exist. But from back here, it should not be too noticeable. You see, even this is still here. Okay. Higher resolution cylinder solves that problem more than this. Okay. And baking gets a little bit trickier on other things when you're doing like subdivision high poly meshes. And I made a video kind of talking about that in a UV mapping video, but there's definitely more tricks to UV mapping and baking than what we've gone over here. But for game models, I think this is a large chunk of the issues you probably will face if you're just doing like static meshes and things like that. So anyways, that's it for this video. I hope you enjoyed. If you want, just throw on some materials and see how it looks as well. It should look correct anyways. So always worth a shot to do that. And just see how it looks. All right. Anyways, I'll see you in the next one. Take care.